Here's our simple interest formula. I equals P times R times T. That's four variables, four pieces of information that have a relationship to each other in this equation. We've used this equation to solve for how much interest for a given principal, rate, and time. But actually, we can use this equation to solve for any of the variables. There are four variables in this equation. If you have three of them, you can get that fourth one. It doesn't have to be solving for I. You could plug them all in except for P. It's all for P. Or RRT. It's like a puzzle. If you have all the pieces but one, if you plug everything in, you're able to find what shape that last piece is. So let's look at page 88 and we'll practice doing that. Take a moment and consider the situation. So we've got a loan. We're trying to find what? The amount that they borrowed. Which letter represents the amount that they borrowed? Hopefully you said P, principal. If so, you're right. Questions 1 and 2 on page 88 are just trying to walk us through this process. We're supposed to identify what the different variables are and what it is that we're looking for. So that's 1 and 2. Now we're ready in question 3 to actually solve the problem. So let's take all these values, plug it in, and do it. I would recommend that you give it a try by yourself, pause the video, and then check yourself. Here's what I got. How did you do? Once again, let me remind you that if you're struggling with one of these things or you're not quite following, you totally have the option to, at this point, just rewind this video and watch that example again. Okay, we're moving on to the next page, 89, number 4. We've got a couple that invested a certain amount of money, $15,250 for 10 years, and they got $9,150 in simple interest. What was the rate that the investment paid? So let's try one more time. Go through and identify what all of the things are that you know. What are the pieces that you have? And after you've identified the pieces that you have, and then the one piece that you're looking for, you'll want to look for an equation that's got all of those pieces. If you have an equation that has more things than more than just one that you don't know, then that one's not going to be as helpful. When we look at this problem, we see that we know P, T, I, and we're looking for R. So even though I see the word simple interest, and another simple interest formula that I know is the formula that has the A in it, it has A, P, T, and R, that's not going to get me what I need, because then I don't know A and I also don't know R. I want an equation that has everything that I need. If you can't find one like that, then you have to do things on multiple steps and be working to find another, but this is not that hard. So we do know an equation that has all of the things, has only things that we know but one, and that's the regular interest one. I equals PRT. So I'm going to plug everything in and solve for the one I'm missing, R. Why don't you pause and give it a shot? Okay, so here's plugging everything in. And then I do some algebra and come up with 0.06 equals R, which as a percentage is 6%. Take a look at number 5. Number 5 is building on number 4. Same situation, same couple, same original amount of money to invest. They're saying, what if instead, it was a 9% interest. And they stopped at that same final amount. How much more quickly would they have gotten there? So identify your letters. Decide, is this still the equation we want? We don't see anything about future value in here. So probably not the A one. So let's plug everything in and see how you do. Okay, one thing I'd like to point out is that in number 5, they tell us our new R. They repeat, tell us letter I, but they don't tell us the principal. However, they are very clearly building on number 4, so that's where we find P. If you're just doing this in your book, it would be really easy to not think, oh yeah, well this question is connected to the last one, but certainly I don't need to look at the previous one, but you do. So our P value is the same, 15,250. What we're looking at, how much more quickly, that has to do with time. Now, we want to, in the back of our mind, think, okay, how much more quickly? I know that has to do with time, but they're not saying how long. They're saying how much more quickly, which means I'm going to need to compare the answer I get with that 10 years originally. If you think that you would forget that, in the excitement of finding T, you would forget that you need that extra step, it might be a good idea to just jot a note. Remind yourself, how much more quickly? 10 minus T equals box, my answer. So here I have my little note to remind myself. After I find T, I still have a little bit left to do. So I went ahead and did all of my algebra, came up with T. That's 6 repeating. You could round that to a 7 at the end there, or you could change it to the fraction equivalent, 6 and 2/3 if you need that. So now that I've got my T, I'm remembering it's how much more quickly, so 10 minus 6.6 repeating, I've got that line over it to mean that it's repeating. Probably what I do, I probably have that 6.6666666 on my calculator screen, so I just do 10 minus answer, and I'd end up with 3.3333333. You could give that as your answer. 3.3333 years faster. You could say that it is 3 1/3 years faster. Or you could even figure out what 1/3 of a year is. 4 months, so 3 years and 4 months.